Now we're going to get into the dirty details of actually solving the quadratic. And just a reminder, if you have solved something, you get to x equals. And so there are 3 different strategies that we talked about with solving. We have solving by factoring. We have solving by complete the square. And we have solving with quadratic formula. Well, solving by factoring is not too shabby. Actually, before I even go into an example, with solving, you best get one side equal to 0 before you start, for heaven's sakes. And I guess that's more particular with factoring and quadratic formula, because with complete the square, we end up like adding stuff over. So if you're going to factor, or if you're going to use quadratic formula, you best set one side equal to 0. Example. Let's say that I have 2x squared plus 10x plus 5 equals 5. Well, I'm going to subtract the 5 first. 2x squared plus 10x equals 0. Okay, I have an x squared and I have another x. So the first thing, I'm going to try factoring this because in my opinion factoring is the fastest and I think it's the simplest. So I'm going to factor out a 2 and an x and I get x plus 5 in the parentheses equals 0. Oh, you want to know why it was so important for us to get one side equal to 0? The 0 product property, homies. Product, stuff being multiplied. 0, stuff being multiplied that equals 0. Well, if you know junk times stuff multiplies to be 0, well, what multiplied by anything gets you 0? 0. So if you have stuff multiplied to be 0, that means that one of those things has to be 0. So I'm just going, okay, 2 times x, or 2 times what gets me 0? 0. What plus 5 gets me 0? Negative 5. So your answers are 0 and negative 5. Great. Let's do another one. Don't worry, I'm just generating these answers on an app first before... Ew, I want gross answers. Give me a gross answer from factoring. There we go. Yes. All right. 3x squared plus 10x plus 11 equals 3. Well, you know me. You know what I like to do. I like to get one side equal to 0 first. 3x squared, I'm subtracting 3 BT dubs, plus 8 equals 0. Darkness, no GCF present. If there was a GCF out front, meaning GCF with no variable. If there is no variable out front, then it doesn't affect any of your answers. Okay, so we get 24 x squared multiplies to 24 and adds to 10. Well, that would be a 6 and a 4. And we cannot use the shortcut since a does not equal 1. So I get 3x squared plus 6x plus 4x plus 8 equals 0. That's me cutting it in half. The GCF of the left side is 3x, so I get x plus 2. The right side is positive 4, so I get x plus 2. Hey, look, they're the same. That means we did it right. So I'm going to write this over to the right so we can see it a little bit better. So I got 3x plus 4 times x plus 2 equals 0. All right, so as far as solving, what plus 2 gets me what plus 2 gets me 0? Negative 2. Okay, let's pretend that this 3 isn't here for a second. Well, that would tell me my answer would be negative 4. But wait a second, we are actually having, it's a 3x. So 3 times something with the negative 4. Well, what's the opposite of timesing? Division. So I'm actually just going to divide by that coefficient on the x there. And that's what we get. And if you weren't sure how I did that, you're always welcome to just set it equal to 0 and figure it out using algebra. Divide both sides by 3. Hey, look, negative 4/3. What do you know? Great. And so, just like I was talking about, I just want to show you something with like a GCF. My answers here are positive 3 and positive 4, because this 2 does not have a variable to it, so it doesn't actually affect the answer. If there was a variable there, like over here, then we'd have x equals 0. Okay, let's talk about completing the square next. And we did this with conic sections. Remember, this is all going to be based off of creating perfect square trinomials. So let's say I have x squared minus 12x plus 7 equals 3. Okay. So typically I would actually subtract that 3 from both sides first, just because then it helps me see if it factors. Okay, what multiplies to 4 but adds to negative 12? Nothing. So that tells me it can't factor. So I'm going to try completing the square. And here's what I'm going to do for completing the square. First, I'm going to move the constant to the other side. And I'm going to leave a blank in its spot on both sides. Because remember, our goal here is to create a perfect square trinomial. And the way we found that is we're going to take our b term and we're going to divide it by 2. So negative 12 divided by 2 gets me negative 6. And then we're going to take that and we're going to square it. Negative 6 squared is 36. And I can't just add 36 to one side, so we're going to add it to the other side as well. So now I'm going to take this perfect square trinomial and we're going to rewrite it as a squared binomial, meaning parentheses squared x. And the way we get that is this guy right there, that b divided by 2 comes down. So I get x minus 6 squared equals 32. So why do we even do it this way? The reason we complete the square is so we can solve using square roots. Because now I could take this and I can square root both sides. I have seen on countless occasions people going like x squared plus 6x equals 5, and I'm going to square root both sides. And you're like, oh, x plus 6. Just so much bad math is happening right now. So much. Okay. You can only, square root cancels out something being squared. It is not something that applies like we talked about. We know 3 squared plus 4 squared equals 5 squared, right? That's Pythagorean triple. 3 plus 4 does not equal 5, friends. So you can't just do that. So we complete the square, so we have one term being squared, which means that exponent is going to cancel out by taking a square root, and I'd just be left with x minus 6. And remember, when we actively take a square root, we do need to have plus or minus. I'm going to break down 32. That's 16 times 2, 4 times 4. There's my group of 2 right there. So we got plus 4 square root of 2. And now we're going to add 6 to both sides, and please add it to the front of the plus or minus. So now we got 6 plus or minus 4 square root of 2. In the past, I talked about how you would, like, the best time to use these things. So, like, for example, the best time to factor is when it factors. The best time to complete the square, what we had said previously is that a equals 1 and b is even. We actually do have the tools now to complete the square if there is. A is not 1. I still wouldn't do it if b was not even. But point is, we can do it that way if we want to. I personally think a equals 1, b is even is still the best time. But if you really like completing the square, here, let's do another example. Let's say you got like 2x squared plus 8x minus 5 equals 0. So if I was going to complete the square on this, this is like what we did with conic sections. Because what we can do is I can factor out that GCF. And let's see, my b divided by 2 is 2. 2 squared gets me 4, so I got a plus 4 here. And remember, what I'm adding to the other side, it's not just that I'm adding 4, it's 2 times 4 because it's in that parentheses, so I'm actually adding 8. And that 2 would come, this becomes x plus 2 squared equals 13. And before I square root, I'd have to divide both sides by 2. And you see how there's no guarantee that this is going to be pretty? Because then we could square root it and all that jazz from there. So in my opinion, I still think this is the best time to complete the squares if a equals 1 is b is even. Because then, if it doesn't meet that criteria, we can use quadratic formula. Which remember is the Pop Goes the Weasel song. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. And what's nice about quadratic formula, it does always work every single time. And so some people, I know you like to just use quadratic formula for everything, and that's fine. It's just horribly inefficient, like horribly inefficient. And I hate inefficiency with a passion. So I'm just going to give you an example. And remember, you best have one side equal to 0. All right. So a equals 11, b equals -6, c equals 12. Because we're going from ax squared plus bx plus c equals 0. And so now I'm going to take all those and I'm just going to plug them into the formula. I think I should color code these. I'm going to say a equals 11, b is -6, c is 12. So I think that's going to help. All right. Okay. I'm just going to fill in those so that we can plug stuff in. Okay. Negative. So see how, like, by having that opposite b there, we're really just switching the sign of b because that negative makes it positive. Let's see. B squared minus 4 times a times c all over 2a. Now it's just a game of simplifying. So that becomes +6 plus or minus the square root. Oh, I forgot to have that squared. 36. Something you can do is just type all of this into your calculator. We call that the discriminant. That b squared minus 4ac. You can type that into your calculator. If you do, and you put in the square root, you're dead in the water. You already got it wrong. So don't do that. Just type in the b squared minus 4ac. Which I'm going to do in my calculator right now. 36 minus 4 times 11 times 12. Negative 492. Now that's fun. All over 22. And now we get the fun job of breaking down the square root of negative 492. Well, here's what I know. That's a negative in there, so we're going to have I, and let's just break down 492. 246. 246 divided by 2 is 123. And it looks like 123 is actually a prime number. So this becomes 2i square root 123. And now our last step is what I call the three musketeers, because these numbers reduce all together or not at all. Leave that square root alone. It stayed inside for a reason. We will not be bothering it. So I'm just going to divide all those by 2. 3 plus or minus, that becomes 1. So I'll just leave it as I, 23. That was a 22 down there, not just a 2. So now that's going to be over 11. And that's how we can leave our answer. So as long as you're comfortable with simplifying, then it's not terrible. It just is a little tedious. So that's why I usually try factoring first. I think we've had enough practice with complete the square. That's not bad. Usually quadratic formula is my last resort.